So, how's it going, everybody? My name is Brian, and some of you I know through the Slack community that I see you're in here. Dale Williams is in here. He's a good friend of mine, happens to work in my organization. But anyway, so I wanted to do a webinar on mobile equipment inspection optimization. And you know, in the maintenance and reliability community, it's very common to have manufacturing and mills, plants, you know, all these places, all these really cool places that unfortunately I've never worked in. But I have done a tremendous amount of work with heavy equipment. So I wanted to kind of share with the community a thing that I call an active inspection. And that active inspection is geared towards mobile equipment from my point of view, because I deal with mobile equipment the most at those terminals, along with cranes and conveyance and stuff like that. But yeah, so it's integrating active inspections into a mobile equipment maintenance strategy. And bear with me, I'm not the best PowerPoint maker. I did put a lot of information in the slides. And also, I have a 1-year-old and a 6-year-old that are upstairs with mommy right now. So if you hear kids, that's why. So just moving on. So you guys don't know me from Adam, okay? My name is Brian. I dropped out of college. I went to automotive school. I was an auto mechanic for a few years. I joined the Navy. I was a GSE troubleshooter. I ran the flight deck of an aircraft carrier during flight operations, troubleshooting and repairing everything you can think of in that list. So when I got out of the Navy, Caterpillar hired me right out of the Navy, where I was a machine technician. I did tons of overhauls on 963 track loaders, compactors, dozers, excavators, wheel loaders, haul trucks, everything you can think of. I am a Caterpillar fanboy. I don't like to argue about the best type of equipment. I just I stick to what I've had the most experience with. When I left Caterpillar, I went to work for a material handling company, and I did a ton of forklift, compact construction equipment, and fully hydraulic and fully electronic machinery troubleshooting in the field. So I am the director of maintenance and reliability for Host. Host Terminals did not have a maintenance program prior to my arrival, where I built and standardized and oversee 6 departments across the country. We have hundreds of pieces of mobile equipment, among tons of other things, like I said, cranes, conveyors, continuous barge unloaders, ship loaders, everything. So just a quick introduction to me. I'm a hands-on background. I always say turn wrenches. That's what I've always done. That's what most of the people that work for me in management have done. They've turned wrenches. So yeah. All right. So just getting into the meat and potatoes of it. Who's heard the below, right? Schedules changed. We need all the machines in rotation. Again, I'm speaking about mobile equipment in this capacity. So I can give you 1 hour, you know, we can swap them for you. You know, once this machine's done, you know, we have to send it to another product because they're behind. We don't have enough machines this week. You know, this machine was just serviced. Why has this failed? And, you know, before you leave shift, oh, just heads up, we're changing commodities tonight, and this machine is going to be doing X instead of Y, which brings that machine into a different operating context, capacity, and environment. So whose operation is similar? So everything below is my operations generally at Host Terminals across all the terminals. So we follow a highly variable schedule. We are a stevedoring company, so everything we do is multi-commodity. Everything we do is on the ship schedule. So it's very hard to have a set guideline of service and inspection and things like that, because you could plan your whole week out, your day out, and it'll change the next day, depending on the ship or barge schedule. Lean operations. Host is a lean company. You know, we have just enough machines and very limited spares to go around. And do you feel like you can never get ahead? You know, the uncertainty in the operation, being able to schedule and perform your inspections and your services. So another thing with mobile equipment on mines and in large facilities, like some of our facilities, you know, Dale Williams works on, he's in the chat, is, you know, 1,000 acres. The one in Baltimore is 3,600 acres. You know, they're huge. Machines go and they disappear. So they're out of sight, out of mind. So an active inspection. An active inspection oh, sorry, how do I go back? An active inspection is, my definition is a rapidly deployable condition-based human inspection designed to provide real-time feedback and verification of defined points. I make the case to note human because, of course, I am always wanting to do condition-based from telematics, from onboard diagnostic systems on machines, and things like that. So that's why I make that distinction. And just like feedback and leadership, I wanted continuous feedback from my machines. I wanted to listen and, most of all, actively engage the team in real-time results and inspection. Extremely invaluable for your team to have, everyone knows this, to have their hands on the components, the machines, and really understand why they're doing what they're doing. And if they can see a direct result as doing that, while they're doing that, that service or that PM or that inspection, it just feeds that real-time results mindset. So the need, this was my need, right? Every organization will have its own unique need to deploy active inspections to their mobile fleet. There's no right or wrong way. Get that out of your head. People try to tell you all the time, this is the right way, this is the right way. Well, it's all about aligning your business objectives with your maintenance program, or aligning your outcomes. What is the company? What is the future? What is the vision of your company? And how does it align with what you're doing for maintenance? So my needs were quickly verify condition, critical safety points and machines, monitor failure modes, engage the maintenance team in failure finding. I wanted to be low intrusiveness. Again, I always try to go back to condition-based telematics, things like that. But sometimes you can't. Sometimes you have to have a human in there looking and inspecting. So, and I wanted it to be a living inspection that can adapt to machine age, environment, and operating context. If any of you are like me, we buy used equipment sometimes, especially for certain applications, and you may be getting a machine that's got 3,000, 4,000, 5,000, 6,000, maybe even 10,000 hours on it, and it requires different points of inspection than a machine would if it had 10 hours on it, right? You know, your mean time to repair, your mean time to failure. I don't like to use MTBF very often, but they're different, right? They're different contexts of that machine's life. So, where to deploy? So time restricted access to machines, fast cycle times, between trucks and commodities and ship schedule, in between scheduled service should operating context, capacity, or environment change, and where utilization-based services, telematics is used, either by operational hours, fluid analysis, or fuel consumption. These strategies can leave a machine out in operation in a way from the shop for long periods of time, not warranting you to pull it out and go to town on it for a full service, but you need to verify certain points and conditions of those components. Mining, guys who are in mining, they know once they they start operation, they put 10 haul trucks in operation, and they got 2 shovels loading 5 trucks at a time. It's very difficult to go to ops and say, hey, we need to do X, Y, and Z, or we've noticed something on the telematics, or the operator's inspection noted something that we need to address. So having a plan to address those things, and we'll get into that. Telematics, host terminals. We are huge on telematics. We put Cat Vision Link on everything, from forklifts to cranes to all the Cat machines. It allows us to efficiently and cost effectively monitor and maintain our machines. So we're not just dropping oil, dropping filters. We're letting real-time utilization dictate how we do our service. So, and I hope to do a webinar on utilization-based service for mobile equipment, because there's so many cool things like fuel consumption, being able to decipher between idle and run time to base your services off of. So very cool stuff. All right, so the creation flow. How do you build, it's just like a PM, right? How do you build an active inspection? How do you build an inspection that can be rapidly deployed to your operation or to a certain piece of equipment or operating environment? So you want to identify the equipment type or operation. I make the distinction there because, for instance, an example, we have machines, 963 track loaders, that we actually fly into the holds of ships, and they push material and dig out under the coaming so that a clamshell bucket can dig the center of the ships out. They are not treated very well in that ship. So the very first active, I didn't even call it an active. So I called it, this was beginning of 2016, I called it a, sorry, that's my dog. I called it a Sorry.
Many of us have dogs. We understand.
I know, Frankie, they're so vocal. So anyway, 2016, I called them pre and post ship inspections, and I tried to schedule them. They were for slag, and I could never schedule them because the ships were always being moved up or pushed back. There was another ship or 2 or 3 ships at the dock. We were moving other commodities on the facility that had nothing to do with ships, and each of the machines were utilized in both capacities. So I decided that, you know what, I'm going to put my PMs and my services on a utilization-based schedule, hours, right? But I'm also going to create my active to where every time one of those track loaders is going into a ship for an operation, they get an active inspection. Every time they come out, they're getting an active inspection. So I was constantly able to monitor the condition of these, and we identified points that we wanted to keep an eye on to make sure there was no avoidable downtime when it was in the ship, because it creates a lot of problems. You have to fly the machine out of the ship sometimes to fix it. You create demurrage issues. So that's why I make that distinction. So define the intended outcome. What do you want from it? What do you want? Do you want to just make sure that you're getting a set of eyes on the machine before it goes into a different operating context? Do you want to take measurements? Do you want to pull fluid analysis? Do you want to create more data points? So define the outcome. What do you want to see from it? And then from the outcome, you'll want to decide what are your critical checks or failure modes. For instance, haul trucks, if you guys deal with fleets of haul trucks, struts, suspension cylinders and struts and things like that are super, super, super important to ride stability, traction control, tire wear, frame distortion, all these things. So simply measuring a strut when it goes from moving coal to moving slag or zinc or gypsum because of the different loads and different environments that the machine is in. Also with hauling as well, right? So at Host, a lot of our facilities, they're not mined, so we don't have haul roads. They're not perfectly maintained haul roads. And a haul truck's meant for haul roads. So there's a lot of things that we developed to try to compensate for the things that we couldn't control. And actives was a fruition of that. So then another thing is you might not normally see is determine the completion time. So if you identify your equipment or the operation, you define what you want from it, you define the critical checks or failure modes you want to address, try to determine how long that will take to do. It could be one thing, it could be 5 things, it could be 10 things. There's no right or wrong. It's just if you determine your completion time, then you'll know how to weigh it against the operation and their schedule. So you'll be able to say, ops manager says, okay, we're running coal tonight. Night shift will have 3 trucks tonight at an hour apiece while we take them out of rotation. Well, if you've established that this inspection or this active that is beneficial to that operation takes 30 minutes, well, then you can get them knocked out pretty quick. Or if it takes 3 hours, well, you might only get 1. So it's good to determine a completion time and then make sure that lines up with your operational schedule, because the operation schedule in some respects is more fixed than the maintenance schedule is, because we're following, right? It's lagging. We have to make adjustments to their adjustments. And then of course you want to build the inspections into your CMMS checklist. You're creating something, right? So you want to reduce the variability. There's nothing better than making sure there's a pass fail or some sort of input or outcome from the inspection, and that should be in the CMMS 100%. And then above it all, train your technicians in the process. They have to know what they're looking for, why they're looking for it, connect them to that process, and you'll find that there's tremendous value in that. Sorry, that was a long one. So it sounds like a PM. You're correct. Fundamentally, it's a preventive process. I do, however, gear it more towards condition-based inspection designed to verify the operating context of machines and components. It's like a super, super souped up critical operator inspection sheet that's done by maintenance to make sure that we're really keeping track of things. So here's some differences, right? And you may have totally differences. You may think these are not different. And that's why it's great that maintenance is such a diverse thing. So designed to be deployed without scheduling, right? On the run changes based around the operation. if you work the waterfront, Dale knows, Scott Funk, who may be on here by now, knows, you got to be on the run. They might take 2 trucks out of rotation on slag and put them on the gypsum ship because they're behind. I mean, it just is nonstop. So ideally, you don't want it to require parts because you want this to be a monitoring condition. You want it to be non-intrusive. So we'll get into some examples I have, I think, on the next slide. So you don't want to just change things to change them. You know, us in maintenance, that's, you know, again, has to align with your business. If that aligns with your business, by all means. But, you know, we want to keep it, we want to monitor things. We want to reduce the impact on the operation as well. So by identifying the completion time, you can gauge the complexity and how much impact to operations. And remember, ideally it's for critical checks only. We don't want to be getting into the machine too much or taking the machine away for too long. That's why it's very important to have your creation flow kind of hashed out to verify what those things are. So here's some types of active checks. These are just ones that we use around. We have tons more. I missed a bunch of them, but these are some good ones, right? So strut height measurements, accumulator pressure checks, hoist brake charge steer, pump pressure checks. The next one, hydraulic cycle times. Those of you working heavy equipment, you should know hydraulic cycle times are so valuable, man. And also we try to trend them when we can, right? Sometimes time doesn't allow, right? But hydraulic cycle times are giving you a tangible understanding of the condition of your hydraulic circuit. So keep that in mind. It's a very good one. Sometimes it takes time to warm the machines up, but ideally if you're pulling them out of rotation, they're already warm, and you can get some good, accurate hydraulic cycle times. Pulling samples. Hell, we pull samples a lot, right? Track tensions, tire pressures if you're not using VIMs. For you that don't know what VIMs is, it's Vehicle Information Management System. Caterpillar uses it to monitor tire pressure, a bunch of other stuff. Implement pins and bushing assemblies, cutting edges, heel plates, cooler inlet outlet ratio temperatures, driveline inspections, and of course, operational checks, test runs, and functional checks. We've found extreme value in doing our own operational checks and our own test runs and our own functional checks on top of operator inspection. Because sometimes they're going through the motions, right? And they've been in that truck for 4 hours, and then the next guy comes on, he gets in it and he goes, and we want to try to be that mediator to really understand the operating context of the machine. And it goes on and on, right? It's whatever you want it to be. Again, there's no right or wrong way. So adding into the CMMS. So the active should be written into the CMMS as a task checklist. Ideally, you want the checklist to identify critical points, have them verified with an outcome. So a function or a measurement or a specification, something that's giving a feedback to the technician. The outcome will dictate the creation of a corrective work order, fail, or continuing on with the inspection, pass. The active process is great at generating value-adding corrective work orders, so long as you use the data in your creation flow. So we all know the term with CMMS is that it's very, very common is crap in, crap out, right? If you're giving it bad information, you're going to get bad information. And it's very important that from the foundation of your inspection, whether it's active, a PM, whatever, is that you're generating good data and you're identifying that data prior to even starting the process and vetting it, making sure that people are on board and aligned with what that data is. Excuse me. And then I wanted to make a key one here, especially with mobile equipment, is the establishment of a hierarchy of critical checks can be used to down, or tag out machines should this critical failed criteria be met, i.e. brake pressure, steering pressure. So the maintenance leadership at Host, they know that you're not gonna go and do an active on a machine and find out it's got 0 brake pressure, or it's got no accumulator charge pressure for the brakes emergencies, or the auto priming lube pump for the engine doesn't work, right? Those are downing things. You're going to cause human life issues or critical issues with the machine. So it's good to establish that hierarchy. So it shows that the maintenance department is vested in making sure that the operation and the people are safe and that we're taking care of those things. So actives can also be tailored to accompany your scheduled PMs. Those of you guys probably know this, or if you've ever been in maintenance departments, I've gone around to tons as a field mechanic, and you see it, right? Unfortunately, heavy and mobile equipment PMs are normally lacking and just dropping fluids and filters. They go in there, 500 hours, engine oil filters, fuel filters, Normally, they don't even clean the machine. They don't grease it. You know, it's very, very, at least in my experience, I've seen a lot of places that are very lacking, no documentation, no nothing, right? So if you build a active inspection, you can build a more in-depth one that accompanies your PM, that more flows with your PM. And we found great results in catching corrective or failure modes before they become a big problem for us and for the operation. And we want to optimize that time. You don't want to just go in there and just drop, okay, send it back out. You want to optimize. So here's my attempt at a CMMS flowchart. All you guys who are good at this type of stuff, take it easy. So active inspection tasks. So if you pass, like, okay, I'll just go to the bottom first. Yes, I use Upkeep, shout out, and created auto-assigning and task field creation flows for active inspections to increase efficiency. It takes the human element out of it. We know if we fail or we pass, something is going to be automatically done that we can address. So it doesn't take someone having to stop, open a work order, assign it, blah, blah, blah. It's all done automatically. So if you pass your tasks, you go on to the next task, and the next task, and the next task until you complete. But it doesn't end there, right? You want to evaluate your active for optimization and failure finding. If you do 100 active inspections in a month or a year and you find nothing, well, that's a problem. You need to evaluate that active to make sure that you're actively engaged in failure finding. It goes both ways. So if you fail, in my system, and I hope that you guys can employ the same things, is, you know, auto correction work order generation. It's going to pop up immediately, and then we're going to schedule or repair based on criticality. If it is one of those hierarchy failure modes, well, then we're going to say, hey, op, sorry, it's done. We got to rebuild this brake pump, or we got to rebuild the steer pump or steer cylinder or something like that. Or it may be I had to adjust the strut height. You can do that real time. It takes 10 minutes. And then, of course, you go back to evaluating it. So evaluate the PM for potential optimization. So then you go back and you look at your PMs. How can you tailor, or how can you optimize the PM, your scheduled PMs, to address the things you're finding in your active inspections? So it goes both ways. And then, of course, we want to see increased availability and added value. I don't like to say reliability because it's inherent, and availability is something that you can kind of get some uptime, right? So we want to add value. That's the whole goal. And all my brothers in heavy equipment, I know how you feel when you feel that it's just like, man, I cannot touch these things. They're out of sight, out of mind. They're on the other side of the mine. I never have an opportunity. Well, try to build those opportunities in and try to really gauge what it takes to do and what you need to do. Need is the real answer there, is what do I need to do to address common problems that we're seeing in our machines, whether it be age-based, environment-based. Maybe one machine goes from working in one mine and it gets trucked up the road to a salt mine, right? There's two different operating contexts, and you're going to look for two different types of issues. So it all flows together, right? Next one here. All right, so the buy-in, right? How do you get technicians to buy into this process? So when a technician is performing an active inspection, they're engaged in critical aspects of the machine, often knowing the outcome of the potential failures. So it's not just a routine PM. It's not them going through the motions, drop oil, you know, grease this, change this. And it plays to the right now results mindset. So if a technician goes to, we say, all right, we have trucks, or we have a loader going from loading coal, and it's going across the property, and it's going to start loading slag. Well, we know, as this is my organization, we know that slag's way heavier. We don't know how long it's going to be there. It could be 5 days, could be 6 days, could be, you know, who knows. So a technician can go, and he's legitimately monitoring this machine during his active. He's hooking up a gauge. He's measuring play. He's doing cycle times. Those are real things that are providing him with real-time results, whether good or bad. And that helps them. That helps them see that what they're doing is generating a result. And when they do find something bad, that builds to them, right? That shows them, oh man, I'm glad we did this, because I would have had to be here at 3 o'clock in the morning, or my brother in the maintenance department could be here at 3 o'clock or on the weekend, and we just stopped that from happening. So then this is my little flow, right? Is Training, you want to train your people the right way to do PMs, actives, whatever it may be. In this case, it's actives. You want to empower them to make the right decisions, to know when to say stop, and you can't use this machine or it's down. Empower them to understand. From empowerment comes autonomy. They'll start to do those things on their own. They'll start to speak highly of those things. They'll start to do those things with others. And eventually you get ownership. And when everyone on here knows, when technicians, electricians, people own what they're doing, they're a part of what they're doing, it has immense value for everyone, right? Collective success. And then you're winning. And that's just a picture of me welding on a 300-ton transporter at Avondale. It's actually one of Dale Williams' machines. I was helping a technician. So feedback. Feedback's important in everything, right? So I reached out to Dale Williams, Scott Funk, some of the maintenance leadership around the company, and I said, how do you think actives have helped us? I mean, they've been in play for 4 years. I started them on paper, and we were manually just going through them, right? So you'll see some consistencies here. So the periodic inspections between scheduled PMs, right? Things do come up, they happen. It's good to keep your eyes on them, especially in critical applications. Can be determined if adjustments to your PMs need to be made, right? We talked about that. Very, very important to be able to constantly get feedback and monitor and adjust the way we're inspecting machines so that we can address failure modes, we can address the environments. And then an accountability standpoint, active inspections allow for M&R to determine if operators are doing what they're supposed to be doing. No pencil whipping. Everyone can agree probably it's pretty common. So there's some accountability there, especially if, you know, really, really fast-paced environments, an operator jumping in a truck, starting and riding off is more common than you think. That was from Dale Williams, and maintenance manager in Avondale, Louisiana. This one is from Scott Funk, the maintenance manager and host in Baltimore. He actually was promoted after I got promoted. So second feedback from him. So they allow us to look over machines more thoroughly and more often, kind of the same note there. Catch failures before they occur. It helps drive the preventive mindset over the reactive mindset, constantly keeping eyes on the machines. And it's a living document. We talked about that. It changes. The active inspection process for our equipment has changed tremendously from when some of the machines we bought were new. That active is different now. 8,000, 10,000 hours later, it's different. The machine is aged before it goes to its first overhaul life. There's different things there to need to be monitored and evaluated. This is a big one. This is every active we do at Host has some form of safety inspection. Fire extinguishers, suppression systems, seat belts, lights, horns, backup alarms, things like that. These are things that are extremely, extremely important, but are often overlooked because they're not a right now problem type thing, except for lights and night shift. And then allows for more frequent fluid analysis, which gives more data points to track fluid trends. It's true. There may be compartments that you want to monitor more often than others. Like new excavators. I'm speaking cat here. New model excavators run 10,000 plus PSI hydraulic circuits. They're very, very, very clean. And it's not like the old G model or H model machines, or however far back they go. It's different. So fluid analysis helps us a good bit there. I don't know how we're doing on time, Caitlin. Am I going too fast?
You're doing great.
Okay. Well, I'm at the end. Crap, I went too fast. So the summary is, above all, align your maintenance strategy, including actives, to your organizational goals and your business strategy. There's no right or wrong way to manage maintenance or assets, so long as the above is true. There's so much data and information overload in maintenance and reliability community, at least in my opinion, and people feel like they're doing something wrong because they're not doing what everyone is saying is the best practice, right? But this is just an example, if your organization is totally okay with you changing an engine in a truck every 2 years just because there's nothing wrong with it, then that's okay. To me, that's like, wow, that's insane. But to your organization, if that's okay, that's okay. It's okay. So remember that. Engage your team. and connect them to the inspection process. Them seeing real-time results and outcomes is invaluable. It's a direct link to their input and the ownership in the process. Extremely invaluable. Guys get so excited when they're like, we brought this truck in, or we went out to the field and this strut was blown out, or the truck was leaning to one side. No one said anything. We had no idea. And the reason we found is because we said we wanted to check this machine before it left slag and went to coal. That was the only reason. And if we hadn't, it would have gone into operation for days away from the shop. We never would have known about it. So then the last one is use your active inspections as a feedback loop for optimizing PMs and the actives themselves to ensure failure finding, operating context, and critical components. We're not perfect. You know, I don't know about everybody's organization, but you may have someone who wrote your PMs just based off of the manufacturer's recommendations. And we all know that generally it doesn't work that well. You know, it's a guideline. Or you may have a single person who wrote it and it wasn't a group of people. Mechanics weren't involved, operators weren't involved. All these key people weren't involved in generating your actives or your PM. So always use it as a feedback loop to kind of gauge where you are and where you need to be in failure finding and addressing your operational needs. So I think I went really fast.
No, you left plenty of time for questions, which we have quite a few.
Okay, cool. So yeah, I'm Brian. You can contact me at brian.bieschke@hostterminals.com. I'm open. I'm on Slack too. Same name, Brian Bieschke. I'm open to talk about anything. I do enjoy mobile equipment. I turned wrenches for mobile equipment for almost 12 years, 13 years. So yeah, I'm open for anything and everything you guys want to talk about. So I'll leave it to you.
Awesome. All right. We have a few questions already from everyone. Thank you so much for that presentation. So Jonathan is wondering, you know, when do we do a mobile equipment inspection if the equipment is on production?
When do you do it if it's on production?
Mm-hmm.
Is it that's where it comes? You have to work with the operational group. There has to be some influence. There has to be some give and take there. You don't want to go to your operations group and say, hey, I know you're running this truck. We want to do a 4-hour service on it. You know, you have to know what you want from the service or the inspection before you go to operations. So if, say you're seeing a trend in fixed displacement gear pumps for brakes. Well, you're starting to see adverse fluid analysis or something. You can go to ops and say, hey, I need 30 minutes to pull both or hydraulic filters to check the screens for metal to make sure that we're not getting crazy here. You know, so come to them with a solution. You know, don't just go, hey, give me the truck. I need this much time. It's, you know, there has to be a give and take there. There has to be some influence there. So that's what I would say. You have to start with ops. Maintenance is a service to the operation. And it's so important that there's relationships there at a high level and even from an intermediate and down to the turning wrenches and operator level.
Excellent. Thank you. Tim is wondering, is there a push to move as much of these checks to a remote monitoring system or a system you can quickly download the data and form an analyzation or trend as possible? So is there a push to move these checks to a remote monitoring system?
Yes, I mean, of course, you know, as I was referencing throughout the presentation, is all of our CAT machines have VisionLink. VisionLink, depending on how sophisticated the ECMs are on the machines, we can monitor strut height, we can monitor brake pump pressures, we can monitor steering pump pressures, we can monitor codes, we can monitor transmission shift points and over temps and all those things. So yes, like I said, that's why I wanted to make the distinction. You want to try to do as much on the line condition monitoring as you can, and we do. But there's some things it just takes a human thought and a human mind to look at, and on top of that, some companies just don't have the money, capacity, you know, leadership, anything to really deploy those technologies. But I 100% I recommend it, no doubt. And Tim, I listened to your Tale of Two Defects, and you got the big stuff, man. I love it. And no, I'm with you, man. If you can condition monitor, you can use your telematics. Yes, that's the goal. That's why I want to do a webinar on that. So yes, the push is to do that. It's just some people, it's not capable, you know.
Tim is also wondering, do you have a process for providing feedback to the operators in regards to faults found on inspections and what might be causing them? So for example, the operator doing something that is influencing the faults.
Yes. So like I said, we will take act. So say a machine goes into operation, we're assuming that the operator inspection is done and they're turned in. They are done. They're done paper wise, right? They're turned into the supervisor, and then they are given to maintenance, whether it's a maintenance manager or maintenance supervisor. And then we go through them to verify things, right? Make sure there's no notes that this truck is puked its guts out onto the ground and whatever. But yeah, so that feedback is generally, it is person to person. When we have our maintenance meetings or morning meetings with operations and things like that, we'll go through, and if we see a trend there, we'll talk about it. But in the CMMS, we have that failure codes, like the corrective failure codes for operator inspection. So if you inspect a machine or an operator inspects a machine and you walk up 5 minutes later to do an active and you find that there's a ton of issues, well, then that's reflected in your CMMS or in upkeep from us.
Great. And then Jonathan is also wondering, what are the critical areas we must inspect during a PM?
Depends on the machine. If you have a machine, I would say generically, if you don't have a machine type you're curious about, is brakes, struts, tires, steering linkages, any kind of, if you guys use, like I'm talking Caterpillar, right? If you use ET and you do any kind of ECM monitoring, anything like that, you can go into the displays on like haul trucks and you can see actives or stored faults, things like that. But safety stuff and critical things first, always first, because you don't want to put the operator in an environment to where they can be hurt, and you don't want a technician being involved, doing something that they don't need to be doing. So criticality, right? Establish the criticality, and then go from there. But if Jonathan, if you have questions on specific machines, feel free to send me a message on Slack, and I'd be happy to help you.
Perfect. Your friend Dale has some questions. So Dale asked, how often would you say active inspections should be collectively evaluated to determine if any modifications should be made? Quarterly, annually, etc.
Well, Dale is the maintenance manager at Avondale, so he can make that call however he so chooses. But no, Dale, I would say it should, how are you trending, right? If you're seeing adverse things on actives very, very often, well, then maybe you need to step that up and it needs to be evaluated sooner than later. If you're not seeing anything at all, well, I would say the same thing, because then you need to optimize the active itself. But 6 months, a year, yeah, I wouldn't say, biannually, annually. But again, it's all about the operation. I know your operation, so probably every 6 months.
Excellent. He has another follow-up question. So, given your particular situation where mobile equipment dominates, how would you recommend a company that is geared more towards a situation like manufacturing? In these environments, machinery idle time may be not as abundant as with mobile equipment.
So if you're talking, idle time, I know you're not talking about engine idle time, but as far as a machine sitting and no one fooling with it, you can, again, it goes back to your unique individual operations. So yes, Dale, we handle mobile equipment, and we try to work as much as we can with the operation to establish these checks whenever we can, whether it be between shifts, whenever it is, we try to establish those checks. I would say in a manufacturing plant or a facility or something like that, where they want to take some sort of active base inspection and apply it to fixed equipment, they would have to do the same. They would have to find, like some places have down days. I just interviewed a guy, a millwright, and he said every Sunday there's no operations, and that's when we do all our maintenance. And I said, well, what do you do during the week to keep a track of your machines? He says, oh, we just walk around and look at them. So it's a hard one. I think it's just going to take that collaboration with ops to understand if a machine is in use or it's running a production run, or are they doing a changeover or something like that. Maybe that's the time. I don't know.
We have a question from Gabriel. How do you select the correct sample of a fleet to evaluate or inspect? So if we have over 1,000 actives, should we inspect every one of them, just the critical ones, or a sample of every equipment type? And if so, how many?
I'm sorry, I don't.
So if you have a really large fleet,
Hmm.
uh, like 1,000, how do
Hmm.
you select, like, do you inspect all of them at the same, like, um,
No,
uh,
it's
pace, or how do you pick how many to inspect or the right, like, sample?
criticality and the operational priorities. In at least in my world, operations as far as mobile equipment, operations is going to dictate the priority. You know, again, it's on our in stevedoring, you have multiple operations going on at one time. So some are more of a priority than others. Some ships you have a certain number of days to load and discharge, and then some they can sit there as long as they want and they'll pay the demurrage, right? So it really depends. In my world, operation is going to dictate the priority, and we are going to set the criticality of those each. So they may say the priority is we have to load the slag ship. Well, in my mind, that says, okay, well then the criticality is our 775s and our track loaders. So you have to do the same thing. If they say we have I'm just making stuff up. I don't know your situation, Gabe, but say you're strip mining or something like, hey, we have to load 1 billion tons of shale. So okay, so that tells me that both our shovels or our whatever and our haul trucks are the criticality for that. You know, you may have 1 billion of them, but you have to prioritize that based on the operation and the criticality of those machines in that operation. At least that's how I do it.
Awesome. That is all the questions we had submitted from today's webinar. Oh no, Scott just snuck one in. So,
Scott who?
Scott Jones.
Oh, okay. Oh, is that? I think that's. I know Scott.
All right, Scott wants to know, how do you rank criticality and what drives the ranking?
The operation. so it's an ever evolving, it's an ever changing thing, right? Like I said, it's so hard for me to mend the manufacturing and the fixed asset and those types of things with the super highly variable waterfront. So I established criticality on a couple things. So operation is going to dictate what we do, right? Or what the priority is as far as monetarily, what is the priority? And then I'll go off of criticality can be as far as, do I have a spare of that machine? You know, the age of that machine, the operating context of that machine. You know, if I have 2 wheel loaders, that one's working in granite or some sort of heavy aggregate, and the other one's working in gypsum, well, I'm going to keep my eyes on the criticality in my opinion would be the one working in a heavy aggregate, because it's a higher duty cycle, it's a higher load based product for that machine than gypsum would be. So there's a whole bunch of things that play into that, and the operation is going to set the priority monetarily. We are going, based off that, we are going to set the criticality based on number of machines, quality of the machine, the products, whatever products that they're working in. Maybe that one is only for 3 shifts and one is for 5. You know, so those all play into that.
Dale has one more question.
Dale, you're killing me. I'm calling you later.
He said, would you agree that equipment with propellers are superior to equipment with tracks? Sorry, had to throw that one in.
I would disagree, Dale. Just so everybody understands that Dale worked on tugboats forever, engine and powertrain mechanic. He's a genius. And when he came over to the dirt world working for me, he gives me nothing but hell about it. So no, Dale, mobile equipment, dirt, tracks, everything is better than propellers.
Amazing. All right. Those are all our questions from today's webinar. Brian, I really appreciate your time this Saturday morning, and to all of our attendees,
Sure.
thank you for joining us. We're going to have more webinars with Brian. I know you have lots of ideas of follow-up presentations we can put together. So keep an eye out in the Slack community for our future presentations with Brian. And then if you have any questions following up from this, maybe Dale, any more specific questions you want to ask, feel free to Slack Brian. He's very active in our community. And again, thank you so much for your time today.
Thank you. Thanks everybody for attending. I hope I wasn't too fast.
You did great. Really, you did great. Have a great rest of your weekend, everyone.
Thank you, guys.